Okay, so hi everyone, I'm Neil, and today I'm going to be talking about how I use Cursor uh, and MCP automation inside of it to automate and accelerate my workflow, specifically my Git-based and project management workflow. So briefly about me, hi, I'm Neil. As I said, I love machine learning, and I've been doing that for around 15 years. I've worked for various companies and I've been doing freelance for the past 4 years. And you can read more about me in the link. So what am I going to discuss today? What are we going to discuss today? First, I'm going to present the problem and try to convince you that there is one. Um, and then I'm going to present the old way of working inside without automations or with very few automations. And following that, I'm going to present the new way, which is the way that I'm currently working. And then I'm going to gradually build upon the old way and get us to the way that I work, to the new way, throughout various editions. First, I'm going to show a basic workflow using Cursor's built-in checks. Then we're going to add cursor rules to that flow, and I'm going to show you how that automates things significantly. And finally, I'm going to add MCP and more cursor rules, and that will get us to the new way, which is my current flow. I'm also going to discuss how MCPs and cursor rules augment one another. And as a bonus, I'm going to show another example, which is going to be a surprise. And there's also references and examples and more discussion in the repository that I've built for this talk, which you can use immediately after I'm finished. So as I said, I'm going to gradually build and get to the flow that I'm using right now. So the first stage is going to be chat-based instructions inside Cursor, which gets us to a nice place, but it's not enough, I think. Then we're going to get to stage 2, which is using Cursor rules for rules-based automation, which gives us an almost end-to-end flow for pull request process. And finally, we're going to get to stage 3, which I call the MCP enhanced workflow, which gives us integration for GitHub and Linear using MCP, and also cross-platform integration between them. And also, I want to stress that I'm presenting a somewhat real project. It's not a project that I've been working on in one of my with one of my clients, obviously, but it's a personal project of mine, of a Telegram bot that I use for tracking thoughts, links, ideas, and to-dos that I've been working on for the past couple of months. It takes all of those from my personal chat and puts them in my Notion. And I'm telling you this because it might come up in the later examples, and also I think it's cooler that I'm actually demonstrating everything on top of a real project and not like a tech demo thing. So as I said, I'm going to present the problem, but do we have a problem? So first of all, I don't think we really have one, but I think we are all here because we want to do the latest and greatest. And manual pull request creation takes time. It takes 5 to 10 minutes. I think I'm being very optimistic here. I think it can also sometimes take 30 minutes. It requires a lot of context switching, which is a pain for me personally. And also the process is inconsistent. Commit and pull request messages are often inconsistent. And also today we have a lot of compliance requirements on top of pull requests, which can also take extra time. For example, there's a compliance requirement for linking between pull requests and project management issues with Jira or with whatever that it is you're working with. So the old way, and I'm saying old with because that's pretty much how we've all been doing things until around, I don't know, 6 months. So it's not that old. I assume that most of us are, at the very least, using Cursor's built-in magic little button here when approaching a new commit. You press that magic button and boom, you're getting a nice commit message. And it's nice, as I said, it's definitely a step up from writing it yourself, but it's based on Git diff. It's not based on like on the overall context. It doesn't have a project-wide knowledge at that point. It doesn't use advanced models, and it doesn't actually traverse my code using the knowledge that it has, the AST. And so, as I said, it's nice, but it's only that. We can do much better. And the new way is, and that's how I work today, and maybe so will you. It has a much broader view of my code. It doesn't just base itself on diffs. It actually goes through the code. And that's and to the right, you can see the way that I actually do it. I go onto the chat and I say, do my Git routine, and then it starts thinking, and it helps you. I'll help you. It helps me. It fetches my Git rules, and it starts traversing my code. It writes a much more thorough commit or a pull request message, and it's simply much better. And that's the actual pull request that it generated with very thorough, not too thorough, not LLM thorough, message that my collaborators can see and read and understand. And Cursor knows about the project. It knows the project's goals. It knows my life goals. It knows who my collaborators are, and if it doesn't, it can infer those from the linked linear or Jira. It can automate much more than just commits, and it ultimately creates a result that I'm very happy with. And this is the way I think to work, considering the power that we have at our disposal. So now we're going to gradually build our solution until we get to that point. So the first stage is basic cursor usage via the built-in chat. We can do that. I suggest to, at the very least, start with that. We can instruct cursor to go through our code, go through the repo, understand previous commits, understand the general scheme of things that I'm trying to accomplish with this pull request process. And it's nice, but it's still mostly manual work, although it does I do that manual work through the chat. The second stage is automation with cursor rules, and that's like the first. I think that's the big jump. Like that's the elbow. Cursor rules are an extremely powerful tool. They can be used for anything from general do's and don'ts in the code, and it can control the way that cursor interacts with me and I interact with cursor. And here's the real example of my always rule. That's like the rule that always fires when I open up cursor's built-in chat. It describes, it tells cursor to be a Python expert and a machine learning expert. It has very brief do's and don'ts, and actually I think the don'ts are the more important. I like them more. I can tell cursor here to never use non-ASCII characters. I hate it when it does those, adds emojis to my code. It looks like a disaster. And also, of course, I tell cursor to never use the dreaded M- character, which simply screams this was LLM generated. I can also tell cursor to stop congratulating me every time I say something. Don't tell me that's a wonderful idea. I know it's a wonderful idea. If you think it's a terrible idea, then I want to hear about it. So with cursor rules, I can tell cursor to exactly how to use Git and GitHub in details. I can tell cursor about personal design decisions like version preferences, styling preferences, framework preferences. I tell cursor to never use Matplotlib because I hate that framework. I tell it to use Plotly. I can tell a cursor rule can also define for themselves when and how they fire within the chat. And I can also always pull them manually, which is sometimes preferable. And I think that's actually something that doesn't work perfect yet. It sometimes doesn't pull them automatically. That part still needs work. Here are two more cursor rules that I use I use extensively, and I'm going to go back to them later. But to the left is my GitHub cursor rule. It's being fetched automatically every time I do something related to Git or GitHub. This is also a place to put project-specific metadata like my GitHub username, the repo name, assignees I put myself because it's a project where only I work. And I also put Uri as a reviewer, but Uri hasn't accepted my invite, so I've been waiting for that to happen. And this goes on, and I have a lot of I instructed the exact flow that I want for commits and pull requests. To the right, I have my linear cursor rules, and also they also have the metadata like the team ID and the label that I want to use. I can also put collaborators uh, and so forth. So going back to automation with cursor rules, I can now instruct cursor to start a pull request routine. It will end with a new feature branch, which we can now commit manually or automatically. I'm still going to need to create that pull request manually, and and there are still other things which are not automated, and I haven't even covered interacting with other tools. For this talk and for this project, and in general, when I get the decision, I use Linear, which is a recent, I think it's recent replacement to Jira, which I'm in love with. And so cursor rules are extremely powerful. They can be used for I've said that before, so that's the flow. It still requires manual labor. That's the point of that slide. And so my question is, can we do better? Obviously we can, and that brings us to stage 3, which is the MCP enabled workflow. This includes interaction with Linear and GitHub MCPs, which is also bidirectional. It can fetch information from both, like my collaborator, the project, previous pull requests, previous commits, the state of the code, and it can also write there. So it can create issues, and it creates pull requests, and it can comment on pull requests. And if I want it, it can also make changes to code inside GitHub. I don't use that, but it can. So MCPs complete the ability to automate almost everything. And it's the first flow that I'm demonstrating today, which is a full end-to-end cycle. What are MCPs? We're going to have an entire day of that, so I only put that as like for completeness. But I do like to think about MCPs as an API that is designed for AI, for LLMs, and not for developers. So that means it's minimal, and it's a focused interface tailored for tool use. And that's the reason it's so effective and so immediate for Cursor to use. And why MCPs? So MCPs are simply an interface between Cursor or any LLM and different external tools. And in our case, it allows for a native issue lookup and updates with both GitHub and Linear. It uses rich metadata, which I've already shown you, labels, assignees, and status. And also, it uses real information over model knowledge. So it has less hallucinations and general model, I don't know, like dumbness. So and it's a level up of our abilities and of Cursor's abilities. It's simply a better and more improved way. So how do I configure MCPs inside Cursor? I'm going to go through this very quickly. It's basically as a JSON. It can be either in your project directory or in Cursor directory. I like to do everything on a per project. This is the GitHub MCP. It's pretty much ready to fire out of the box. If you use my repository, you only need to put your personal access token, and you're pretty much ready to go. And for the sake of this talk, I'm using 3 MCPs, GitHub, Linear, and also Context 7. So going back to the MCP enabled workflow, there's one more thing I wanna stress, which I find extremely important, and it's the command deny list. If you're using Cursor in what they call YOLO mode, which means it simply runs through everything, you do want to create a very thorough command deny list, which are the commands that Cursor will not run automatically. And make sure to put everything potentially destructive or irreversible in here, like pushing and file deletion, creating new branches, everything that you don't want it to do automatically, everything you want to review, also any interaction which is not like get, I don't want it to do automatically, pretty much. And of course, sudo. Don't let it do anything sudo. God, I've heard difficult stories. So now I'm going to demonstrate the full routine end-to-end, almost end-to-end. So as I've shown you earlier, I'm going to go onto the chat and tell Cursor to do my Git routine. It's going to plan the next move and think for a couple of seconds. And after thinking for 5 seconds, it sees that I'm currently on the main branch. I have some modified files. So first, it's going to fetch to fetch the fetch origin, make sure that I'm up to date with the master branch. It's going to create a feature branch because that's what I've told it to do, unless I'm already on a feature branch. And then it's going to think a bit more. It's going to iterate through my code thoroughly and start to create a list of changes which is smart and informed and based on real context rather than on tunnel vision of just diffs on the files. And now, like, the magic starts happening. I actually see that it uses Linear's MCP to call create issue, and it's creating an issue on my Linear board. And I see the Linear issue created and comprehensive error handling and retry logic. Now I can also see the actual issue that was created. And of course, it can also add labels and tag whoever I want. It can give a default priority to issues, or we can also tell it to try to infer their priority. And now it continues. So it's created the pull request, and now it calls it again to add to update the message and add various things to that pull request So here's the pull request that it's created. It's thorough. It admits a very specific format that I have created for it. So that really helps with that consistency I've talked about earlier. Pull requests are pretty much going to always look the same. And I'm trying to also instruct it to avoid LLM speak and like don't be overly verbose and don't speak like a human. And also it created a link between the pull request and the Linear issue, which is something that I need for compliance. So as you can see, my CI catch the Linear issue in the pull request, and that test passed successfully. I failed with Pyrites. I fixed that later. I also get a nice summary, which is nice. We can conclude the process and see that Cursor also understands everything that has been done. It's also a good place to check for errors that have been made. It created a Linear issue. It created the pull request. It linked between them. It created a feature branch and everything else. And it's ready for review by Uri. Uri, I'm still waiting. Going back to cursorrules, because now with MCPs, they become even more important. MCPs require very descriptive cursorrules. The repo I've contains a lot of examples, contains the cursorrules that I use pretty much. Also, being an API, MCPs need authentication, and that's a pretty annoying part because there's no standard yet. So that mostly wrappers around existing APIs. So Linear requires OAuth, and GitHub requires a token. And MCPs need to know my GitHub username, project IDs I've shown you earlier. So that's cursorrules are the place to put those. And by the way, for Linear, because it uses ideas, you can actually use MCP inside the chat to get those ideas and put them in your cursorrules. So recapping the MCP-enabled workflow, the new way, full file changed, created a feature branch, blah, blah, blah. It took around 30 seconds end-to-end, which is amazing. It saved me so much time. I can have like 2 cups of coffee in that time. And also the presentation repo itself was built only using this workflow, which is nice. זה לא מחביא, hidden slides. Okay, and now a bonus. Using context 7 for keeping your code up to date. So that's another MCP that is disconnected from the workflow I've shown you up to this point. And it solves a new problem. The problem is outdated documentation or training when adding new dependencies to your code. Context 7 can import real-time documentation for the code that we use. And implementing it is also very straightforward. I add to my Python general rules, I tell you that when documentation is lacking or when inserting new dependencies to my code. And that prevents the problem of the various models that Cursor uses from improvising and hallucinating or using deprecated code, which happens a lot. So it provides real-time documentation for almost 6,000 libraries in various coding languages. It has the latest API changes and best practices for each one of them. And as I said, it prevents hallucinations and errors. And as before, it has a seamless integration with Cursor. So here's an example. I've asked Cursor to generate a reversal code for me using Shapely and NetworkX, which I use a lot, not in this project. And they didn't exist in this project because I don't need graph reversal in a Telegram bot. But because they didn't exist, it fetches those two libraries from context 7, as you can see to your left. And perfect, it found the library IDs, and now it can continue and fetch the relevant documentation and best practices. And every code that it will write from this point on in this chat, based on those two libraries, is going to use up-to-date code and up-to-date methods. And also as a bonus, because I've instructed Cursor to do that in my Cursor rules, it also knows that when I add a new dependency, it knows to add those to add it to my package management UV in my instance, which I'm also in love with and I recommend wholeheartedly. And also it knows where to put the new utils py file because I told it in my Cursor rules where to put new files. So wrapping up, we've upgraded our workflow significantly using MCPs and Cursor rules. And this flow, the usage of rules and MCPs translates very easily into Cloud Code and other similar coding LLM-based utils. I haven't tested it with the new recent Gemini code, but I think it will probably be the same. You can try everything immediately now in the code and the examples and the rules themselves. They are in my repo, which you can clone. Tell me if you think I've made any mistakes or if I think I can improve this even more. And you can also talk to me and you can now ask questions.